Hello friends, today I'm going to show you how to create machine learning model, a regression model in under 1 minute. It will be based on Boston housing dataset. Then I'm going to show you how to predict based on this model, how to understand key drivers and or key feature importances driving house prices in Boston, and finally how to predict based on this model. So stay tuned. The dataset we're going to talk about is a Boston housing dataset. The legend of the column names is here. So we are talking every row is one house in Boston. The most important column that will be our target column is the median value in thousands of dollars, the median, the price. So we are talking about columns like crime per capita rate, the proportional residential land zones, all the way to the different ratios like LSTAT will be very important, lower status of population in percent, and so on, number of rooms, age, and so on. So based on all these columns or features, we want to train machine learning model to understand the price, what is driving the price, and then we want to be able to predict house pricing based on this trained machine learning model. So back from the data set, let me jump to Graphite Node. I'm going to use Graphite Node for no-code and AutoML machine learning training. I uploaded this CSV data that I just showed you here. So this is my data, 15 columns. 333 is number of rows. I have a neat summary here, so I can see the distribution of the age or crime rates or the lower status percentage of people. So what's the distribution here? And finally, I have my my median number. This will be my target column. So this is essentially the price of the house. Based on this dataset, so Boston Houses trained dataset, let us create a machine learning model. I will go to the models and new model. Since I want to predict a number, I'm using regression Graphite Node, and that number is the median value house price. I'm going to use Boston Housing trained dataset that I just showed you, and I'm going to create a model. Now we are going through a very simple scenario in Graphite Node. I need to select a target feature or column. So this is what I want to predict. We already established that will be my median value price. Then I go to the next step. We discarded ID from the dataset because it has more than 90% unique value, so ID cannot bring any new value to the ID of the house to the price, definitely. So we are going with the default, selecting all the other features here. This is the fun part if you're a data scientist. So we're going to run through all these machine learning algorithms, and we are going to fine-tune the winning algorithm to find the most accurate model fit. And then later we are going to create actionable insights. I'm going to dive deeper into that in a minute. Actionable insights with my goal is to increase the average of the house price. And the next step is just run scenario. So I'm going to click run scenario button now and pause the video. Okay, so the model is run. In under 30 seconds, we run to all these algorithms and we found that the winning algorithm is random forest, and then we optimized that algorithm more with fine-tuning, and actually these are all the hyperparameters. If you're a data scientist, you will want to see this. But let me just jump straight to the overview of the model created. In 30 seconds, we have incredibly accurate score for the model fit. We are explaining everything that we did here, so you are free to explore the whole narrative of what we built under the hood based on what kind of data. You have a model health check, explanations of performance metrics, so everything that you need to understand exactly what is the model about and what it does. But I really love this part. So now we are exploring what are the key drivers driving the average of price going up. So the four most important columns in our dataset are the low status percentage of people with low status around the house, the number of rooms, the distance from employment centers, and crime rate. All the others are really not that important. So that's the first win from the model. You know exactly what is important in driving the average of price going up. And then even further, for every column, we know that this is the sweet spot. So below 7% is the sweet spot to drive 7% of lower status people around the house is the sweet spot driving 38% more price up than compared to the other buckets. Number of rooms, everything about or just about 7 rooms or above is a sweet spot for optimizing or maximizing the average of price going up again. And you can explore this for every column in the dataset. So this is incredibly powerful in this understanding what are the key drivers driving price of the house going up. Now you can go to more details here, but let me just switch to the actionable insights we are providing. So essentially, we are giving you a strategy. If your goal is to increase the price in Boston, house price, this is your strategy. And it's incredibly important, again, to state that without machine learning model, if you remember, we had 15 columns here. So without machine learning model, you actually don't know what to focus on. Is this the tax ratio or number of rooms or distance from the center or distance from employment centers like this column here? But with a trained machine learning model, essentially, you know, you should focus on these 4 columns. Everything else is actually not driving price going up or down. And then we are giving you the global strategy and all the actionable insights. If this is your business use case, we will give you actionable insights how to achieve your goal, which is I want the prices to go up. For example, for distance from employment centers, we are promoting suburban developments as a goal, and we are answering 3 times why. because greater distance is weakly positively correlated to the price, because it can lead to creation of desirable residential areas with high property values, and because attractive neighbors can draw affluent residents, enhancing the overall market stability. We are explaining this for every column in your dataset, so the full strategy document. And of course, the predictive model, point of the predictive model is to predict something. So now, with again, under 30 seconds, we created all these strategies here. We deployed the model in Graphite Node in the cloud. You can actually predict. You can play with what-if observations. If I have 70% low-status people around the house, and I have 4 rooms, etc., etc., the predicted price is $19.5 thousand. But if the same house is in the area with only 5% of low-status people, the price will be 42, or it should be 42. And that's kind of the point, because now with new houses on the market and the model in place, I can actually predict price, what should be the price based on the model and historical data for every house. So I can upload my CSV data. So these houses are for predictions. These houses were not part of the model training. I'm going to predict each row here very easily in Graphite Node. So every new house that comes to the market, I can predict and strategize. This is what the price should look like based on all the columns and historical data and the trained machine learning model. So this is an incredibly powerful example how regression in machine learning works. So whenever you have any number or KPI in your business, is it a revenue or price or scrap material percentage in manufacturing, number of hours developing something, whatever is your KPI, it's a number. So you can use regression to understand all the key drivers driving this number going up or down. You can understand your data. You will get a full strategy document, how to increase or decrease your number depending on the use case. And you will be able to predict what's going to happen in the future based on the trained model. Hope that you will find this useful. Cheers.